So in this concept, we're going to continue talking about the different types of transformations. And in this case, the transformation we're going to talk about is a reflection. So a reflection is flipping a figure over a certain line of symmetry. It could be the line of symmetry could be an axis, could be an arbitrary line drawn in the coordinate plane. When flipping a figure, the figures are mirror images of each other, in which case the shape and size does not change between the original figure and its mirror image, but the orientation is different from the original figure. So the orientation between the original figure and the mirror image of the figure is different. To reflect a point over the x-axis, right? So coordinate plane, right? X, Y, right? So if we had a point somewhere here to reflect the point over the x-axis, right? The x-coordinate, as you can see, would be the same, right? So the x-coordinate of this point is the same as the x-coordinate of this point. However, the y-coordinate is essentially multiplied by -1. It's negated, okay? You take the negative of the y-coordinate. So let's put some rough numbers. Let's say this were 3, right? So 1, 2, 3, 3 on x. But on y, let's say this were, well, also 3, right? So if this were 3, to flip it down, this would essentially be -3. So the x is the same, but the y is essentially multiplied by -1 when doing a transformation over the x-axis. Let's look at this example. Reflect the following point over the x-axis. So you have point A -1 and 1. And it is located here. So -1 on x and 1 on y. Now, when we go to reflect it over the x-axis, again, the x-coordinate remains the same between the original point and its image, its mirror image, or its reflection, whereas the y-coordinate essentially gets multiplied by -1. So you go from 1 to -1, right? The transformed point, like we presented in the previous concept, is referred to as, the main point prime. So this is point A. Its transformation or reflection in this case would be A prime. Okay, so the reflection of A, having coordinates -1 and 1, is A prime, having coordinates -1, -1. This is the reflection of A over the x-axis. Okay? Let's look at this second example. Reflect the following points of the triangle ABC over the x-axis. So remember, again, to reflect over the x-axis, you keep the x-coordinate the same, and you multiply the y-coordinate by -1. So these 3 points are essentially vertices of a triangle, right? Having the respective coordinates that they have. So point A, or vertex A, is located at -3 and 2. So -3 on x, and then up 2 on y. This is point A. The reflection of that becomes -3, -2. Again, the x-coordinate remains the same. The y-coordinate is multiplied by -1. For vertex B, you do the same process. X-coordinate remains the same. Y-coordinate gets multiplied by -1 because we're reflecting over the x-axis. For vertex C or point C, the x-coordinate also remains the same. The y-coordinate goes from 1 to -1, gets multiplied by -1. Okay? In general, when reflecting over x, over the x-axis, we multiply the y-coordinate by -1. Okay, so in the generalized case, again, point A having coordinates, initial coordinates x and y, becomes A prime having coordinates x and -y. Now, let's look at reflecting over the y-axis. So for the x-axis, like we said, we kept the x component, or the x-coordinate, the same for a point, and we multiplied the y-coordinate, or the y-component, by -1. For the y-axis, it's the exact opposite. So the y-coordinate remains the same for reflecting over the y-axis, right? The y-coordinate remains the same, but the x-coordinate is multiplied by -1. So it's the opposite. Let's look at this example. Reflect the following points of the triangle ABC over the y-axis. And here you can see the original triangle, point A -3 and 2, right? So this is point A. Point B -1 and 2. This is point B. Point C -2 and 1, right? So the reflection of point A is which is -3 and 2. The reflection becomes A prime, which is 3 and 2. So in this case, the x is multiplied by -1, whereas y is just the same, right? The same, you do the same thing for B and C. So the x-coordinate changes, is multiplied by -1, and the y-coordinate remains the same. The same thing for C. So when reflecting over the y-axis, we multiply the x-coordinate by -1. So in the generalized case again, for reflecting over the y-axis, you have the point A with initial coordinates x and y is now reflected into point A prime having coordinates -x and y. So here we have a quick exercise. Please pause the video, try to work on this on your own, and come back for the solution. Okay, so let's try to find the reflection of this shape, which happens to be a square. So you do have 4 points here representing the 4 corners of a square. So we'd like to reflect this square over the x-axis first, and then over the y-axis. You are welcome to draw this so you can better visualize it if you are a visual person and you need to visualize things. But again, you don't really have to. You just have to remember that, again, to carry out the transformation of reflecting, or a reflection over a certain axis, you keep one of the coordinates the same, and then you multiply the other coordinate by -1, depending on which axis you need to be reflecting over. So in the case of the x-axis, again, we keep the x-coordinate the same, but we multiply the y-coordinate by -1. So let's do part A here and part B here, right? So to reflect over the x-axis, we have W, point W, which initially is -2 and 1, becomes W prime, which is, again, since this is reflecting over the x-axis, you keep the x component the same, but the y component becomes, or gets multiplied by -1. w, and then x, 2 and 2 becomes x prime, which is 2 and minus 2. Point y, which is 3 and minus 2, becomes y prime, which is 3 and 2. Right? Again, minus 2 times negative 1. Point z, which is minus 1 and minus 3, becomes z prime, which is minus 1 and 3. Okay, so this is the result for reflecting over the x-axis. Now we need to reflect the same object, square wxyz, over the y-axis. So again, the process is very similar. For reflecting over the y-axis, the y component remains the same, whereas the x component gets multiplied by negative 1. So for point w minus 2 and 1, reflecting over y gives w prime of 2 and 1. X with point 2 and 2 becomes x prime with point minus 2 and 2. Y with point 3 minus 2 becomes y prime with point minus 3 and minus 2. Z with point minus 1 and minus 3 becomes z prime with point 1 and minus 3. Okay, so these are the results for reflecting on the y-axis. And this is it for this concept. See you in the next video.